So we're now going to start taking a look at a case study, which I call the BerraQuotes app. You'll see why we call it the BerraQuotes app in a moment. And this is a multi-part case study that will walk through what you need to do in order to build a Spring-based application on both the server and client sides. And we'll also show how functional programming and various other parts of modern Java and very modern Java can be applied using Spring Web MVC to obtain quotes by the famous baseball player and manager Yogi Berra. And you'll see he has a bunch of funny quotes. He's known for saying so-called Berra-isms like, it ain't over till it's over. That's one of his famous quotes. So we'll see a bunch of other quotes too. So you can find this particular application in my GitHub repository, in the EX2 project, in the Web MVC folder, in my live lessons repo. So you're welcome to clone this repo and take a look at the code and follow along, or take a look later at your convenience. As you can see, it's a client-server application. We've got the BerraQuotes application on the right-hand side. That's the server side. The BerraQuotes test, which is on the left-hand side, that's the client. And they communicate by sending synchronous HTTP GET requests and responses. So let's take a look and see how we can use this to implement a very, very simple microservice. And this microservice is actually going to have a number of different strategies in its implementation. It's going to have one that's going to use a sequential stream, a parallel stream. It's going to use structured concurrency, and there's a couple variants of all this stuff. And as you can see here, the client is single-threaded, just one thread, and the server will be multi-threaded, depending on what variant of the implementation strategy we're using. You can also see here we've got other things that I've mentioned before, like controllers and services and so on. The client, as we'll see when we look at the example in more detail, can send requests either individually or in bulk. So it can either send one at a time, or it can send a bunch of requests and then get back a list of results. The server, which is a microservice, can also receive the requests individually if they're sent individually by the client, or in bulk if the client sends them in bulk. There's a controller called the BerraQuotes controller that automatically converts the HTTP GET requests into the corresponding Java types, things like strings or list of strings or integers. And then these types are, the instances of these types are then forwarded to the BerraQuotes service. And the BerraQuotes service, in turn, then forwards the request to the indicated implementation strategy, such as sequential streams or parallel streams or structured concurrency and whatnot. And then it returns a list of the corresponding Yogi Berra quotes. That's what the implementation strategy does. And it gets this by searching literally a list, an array list that's stored in memory. So once the implementation strategy is forwarded to by the service, it does the work, performs the requests, and then returns the results back to the client. So let's talk about how this app is actually structured. And I'm doing this for a couple reasons. Give you an overview of what we're going to cover before we look at the code, but also to give you a sense of how well-structured Spring applications are typically designed. So here we have the client side and the server side. Let's take a look at the server side first. There's basically a BerraQuotes package. And in the BerraQuotes package, it contains a bunch of relevant things. So it's got the server portion that has the app entry point, and we'll talk about what that is in a moment. The controller instance that we implement, the service that we implement, and then the various implementation strategies. So we typically put those things in one place so they're easy to find and easy to understand. We also have another folder or package called Common. And this is where we consolidate various project-specific helper classes. These are things that make sense in the context of this particular application. So we have an object called a quote object that will keep track of a Yogi Berra quote. We keep track of some constants that we use to identify particular endpoints or various parameters, and so on. We also have some general purpose utilities that could be used for many different kinds of of applications, not just the BerraQuotes app. And in this, we're going to have some utilities for handling regular expressions, as well as dealing with Java futures. We'll talk about why we need that later. And then the final piece is another folder called resources, which has a file that defines various application properties, like what's the name of this application. It's obviously BerraQuotes, and what's the port number that it's going to listen on to receive requests from the client. There are many other ways of doing this. This is a very simple way of doing it just to get us started. This resources folder or package also contains the list of Yogi Berra quotes as a text file. There's also the client side where we have the test driver, and that's what will use the other parts of the client implementation to initiate calls on the BerraQuotes microservice. We've got essentially a client proxy portion where we have the BerraQuotes client, the BerraQuotes proxy. We'll see that the BerraQuotes client looks like method calls that are just good old Java method calls. The BerraQuotes proxy is what the BerraQuotes client's methods call, and that performs the translation or transformation from native Java code into the underlying HTTP requests that will be sent across the network. And then we also have these common utils. There's utils for dealing with random number generation. There's a util that keeps track of timing, how long it takes to run method requests. And there's also a util class that will do the transformation from native Java types into HTTP requests, filling in the appropriate portions of the request header so it has the information we need to talk to the server. There are pros and cons of the way we're doing things here. The benefits of this particular app are it's very simple. It's a good place to start. The service implementations, and there's 4 or 5 of them, all run within a single process, which makes it easy to configure and deploy because we just run it in one process. We don't have to worry about orchestration or running multiple microservices and starting them up in the right order and so on. It also greatly simplifies testing, and you'll see that when we get to the test driver, because we can write a unit test that exercises the features, and we can automatically start up this server process, and it does its thing, and it's really easy to work with. And it also makes security a little easier because everything's in one place. So if we need to do any kind of authentication or authorization, that can be consolidated in one place in our solution. However, not everything is unicorns and rainbows, as I say all the time. And there are some downsides. Because everything runs in a single process, we might actually degrade system scalability. If you had lots and lots of clients that are banging away on the BerraQuotes server, that could become a point of contention, single point of contention. And we might also have some issues if this process were to crash, then we would have a single point of failure. So very simple, good starting point, but be aware that production grade web applications rarely are implemented in this way anymore. And I'm just doing it this way so we get started with something that's easy to understand and we can focus on the key pieces that are necessary now without getting distracted by all the other stuff we have to worry about. So that's the end of the overview of the BerraQuotes case study.